The idea behind logarithms is very similar to, for example, radicals with exponents. For example, if you square something, then you can actually take a square root to be able to get back to the original answer. Well, logarithms are very useful in such a way. Also, for example, if we take a look at this exponential equation, even something simple like 2 to the power of x is equal to 3, we actually cannot solve it directly without the use of logarithms. So what can we do? We can define logarithm in functions. So let's take a look. Each logarithm is coupled with its own version of an exponential equation. So for example, if the base a to the power of x is equal to y, it's actually the same thing if we rearrange it slightly as the logarithm of base a. It's the same base as in this exponential equation of y. The answer in this equation is equal to the exponent x. So this is the way to bring the exponents down if we define them as logarithms. So we read it as a log base a of y is x. So in a way, the logarithms are inverse functions of exponential functions. And inverses is the same thing as, again, exponents and radicals as a way to get back to the original answer. As for example, if you raise something to the exponent x, we can actually get back by taking the logarithm, but more on that later. Let's take a look at some examples. Some exponents, for example, some logarithms we will be able to calculate without the use of calculators because it can be tricky with different bases depending on which version of the calculator you have. But we can easily translate from the exponential form, for example, to the log form. Notice the log of base 5 of 25 is actually 2 because 5 squared is equal to 25. That's how we can quickly check it. Or log of base 10 of 1, the answer is equal to 0 because 10, or any number for that reason, except for 0 itself, to the power of 0 is equal to 1. Sometimes, if you ever see that the logarithm, that the base is missing, what it means is actually log base 10 is the same thing as a common logarithm. So any logarithms with base 10, sometimes we don't write the 10. Sometimes it's called the common logarithm. That's true. So log base 10 of the value is the same as just a simple log. And another log that has a special notation is called a natural log, and it's also written as simply ln. ln is a log of base e. So let's take a look. So log of base 10 is the same as a log. Log of base e is the same as ln. Both of these, log and ln, are located on most calculators. So even scientific or graphing, for example, TI-83 or TI-84 would have these bases right here. So we can input those in the calculator, or we can use something that's called change of base to be able to input any logarithm into the calculator. So we can calculate some of them. Let's take a look. And we can also, let's take a look at example 3. Let's try to compute some more logarithms. Let's say logarithm of base 5 of 125. Well, you can ask yourself 5 to which power is equal to 125? Well, the answer would be 3, or third power. So the answer is 3. Right here. Now, what about log of 10,000, let's say? Well, notice there is no base, which means it's base 10. So 10 to which power is equal to 10,000? Well, the answer is very simple. Notice we have 4 zeros in 10,000, which must mean it's 10 to the 4th power, which is indeed true. So the answer would be 4. So the log of 10,000 is equal to 4. And you can actually input it in the calculator and find that it is the correct answer. What about something like log base 2 of 1/8? What if we have a fraction? Or 2 to which power is equal to 1 over 8? Well, if you recall that a to the negative power of x is equal to 1 over 8, well then we can simply figure out 2 to which power, or x, is equal to 1 over 8. Well, we know that x has to be negative to be able to go to the denominator, and also 2 times 2 times 2, third power, would give us 8. So 2 to the negative third power is equal to 1 over 2 to the third, which is 1 over 8. So that's how we know. Let's take a look at one more example. What about 16, log base of 16 of 2? Let me sort of not let you see the answer yet. Well, same idea. 16 to which power is equal to 2? Well, how can we get a smaller number here? Well, if we have radicals, we will be able to do that. Or we can simply translate it to the same base, how we do it usually. So we know that 2 to the 4 is 16 equals to 2, which means that 2 to the 4x, if we know the property of exponents, we'll multiply them here, is equal to 2. Well, that must mean that 4x is equal to 1. Notice, because the power of 1 here. Well, that means x is 1/4. And notice, x of 1/4 is the same thing as a radical. So for example, fourth radical of 16 is equal to 16 to the 1/4 power. They are the same thing, and they both are equal to 2. So our answer here is 1/4. So any negative powers, like we see over here, give us fractions in the answer. Any fractional powers actually give us radicals. So that's how we know. And that's it about the logarithms for now.